All right, good morning, everyone. Uh, Good morning and welcome to today's presentation. My name is Michael Martinello. I'm the Director of Sales for ALS Global, and we thank you all for joining us today for the webinar, Utilizing Your Data, Incorporating Data Analysis into Your Oil Analysis Program. If you've ever felt like your maintenance strategy could be smarter, less reactive, more efficient, and backed by real-world insights, you're in the right place today. We're going to explore how you can move beyond the guesswork of preset maintenance schedules and start using your oil analysis data to its fullest potential. Leading today's session is Harold Scarborough, Technical Project Manager at ALS Services USA. Harold is an expert in tribology and predictive maintenance, with a strong focus on turning data into actionable insights. With nearly a decade of experience in the industrial lab testing and deep understanding of lubrication performance, he's helped countless organizations reduce downtime, extend oil drain intervals, and make smarter maintenance decisions. We're excited to have Harold here to share his expertise and walk us through real-world strategies for using oil analysis to transform equipment maintenance. Before we get started in the presentation, we have set everybody's cameras and microphones to be off. If you have any questions throughout the presentation, please use the Q&A section, which you will find on the top banner of the Teams. If you have any questions throughout the presentation, please leave those questions there, and Harold will address them in the Q&A section. Without further ado, Harold, over to you.
All right, thanks, Michael, for the introduction. Like Michael said, I'm the Technical Project Manager for ALS Oils and Lubricants. That usually entails working with clients to make sure that their technical needs are met, whether that need is training, report review, or simply answering questions. However, the real area where I provide assistance is utilizing data analysis to help solve customers' unique problems. Before we start looking at data analysis, we should quickly review what the benefits of oil analysis are, as we'll be discussing each in depth. Obviously, if you're going to be sampling your equipment, you want to see what kind of state it's in. Oil analysis allows you to monitor your equipment's performance to ensure that it is performing at an optimal level and that there aren't any major problems occurring internally. On the flip side of that coin, fluid performance is also a key insight shown by analyzing your equipment. Things such as base number, oxidation, and viscosity will give you insights into how the fluid is performing for your specific situation. By zooming out and taking a look at your program as a whole, you can catch poor maintenance practices and take steps to make sure that your maintenance department is doing their due diligence. Learning how to reduce waste is also a key insight that can be gleaned from oil analysis. By optimizing drain intervals and picking the correct parts, you can streamline your maintenance department and select the fluids or equipment that are best for your particular situation. Finally, the most referred to benefit, catching failures before they happen. By monitoring your oil analysis results, many failures can be averted or mitigated, and maintenance can be performed with minimal impact to your business. All of these use cases are applicable for all oil analysis programs. However, these insights can be difficult to manage when looking at a maintenance program as a whole. When looking at a maintenance program from the top down, what people don't realize is how much untapped potential they are sitting on with their historical oil analysis data. By leveraging the data you've already accumulated, modifications to your maintenance strategy, alert levels, equipment selection, and fluid decisions can be made intelligently and with the data to back it up. Most companies utilize pre-built general recommendations for their equipment's fluid and maintenance program. We'll go over why those are necessary in a moment, but keep in mind, with the power of data analytics, you can unlock the hidden potential that is contained within your data to make your program work for you. As mentioned, recommendations are made to fit a wide range of applications. But if recommendations specific to you are superior to generalized ones, why do we use them? Unfortunately, due to the varying nature of applications machines get brought into, it is impossible to be hyper-specific on a nationwide scale. Equipment manufacturers, oil providers, oil analysis labs, and even maintenance managers all have to rely on some level of generalization when determining recommendations based on oil analysis results. To determine these generalizations, manufacturers typically will put each part or oil through an extensive testing process to determine its ability to handle extreme situations. Likewise, oil analysis labs take a broad look at historical trends across compartment types to see how they wear over time. Maintenance managers, on the other hand, have to be able to have rough generalizations of how their equipment operates so they can make long-term strategies regarding part acquisition and maintenance practices. In order to meet the needs of a majority of the use cases of each item, generalizations need to be made to try and capture as much of the quote unquote normal population as possible. This tends to make recommendations more generic and wider. Think big box store suits versus one that was specifically tailored for you. This obviously has ramifications for customers who want to have a little bit more nuance to their program. Their situation might be unique, and as we know, not all situations are equal. Let's look at a couple of examples to sort of illustrate this point. Let's take two dump trucks of the same Model X using the same oil that are used by two different companies that are both running oil analysis programs. Company A runs the truck with an average maintenance program, carries pretty heavy loads, and has an average drain interval. Company B, on the other hand, has an excellent maintenance program, runs lighter overall loads, and their vehicles have a shorter drain interval. Both vehicles aren't really getting flagged that often by their oil analysis provider, but do you think what they consider normal is the same? Company B likely has a much lower baseline wear level due to its maintenance and operating practices, and therefore what is considered statistically relevant change in wear rates are going to be different for them than Company A. A 10 parts per million increase in, say, iron might be a commonplace occurrence for Company A, but to Company B, that is a statistical outlier and should be investigated. This can also extend to other things like contaminants. Let's take two long-haul trucking companies operating identical trucks and oil, with one in Arkansas and one in Michigan. Both are seeing sodium appear in their oil analysis results and both are concerned about coolant leaks, as sodium is an indicator of coolant. Arkansas company tears down their trucks in question and finds the coolant leaks. They are repaired, and oil analysis has done its job at catching the problems before they become failures. Michigan company, on the other hand, also tears down their trucks but finds no coolant leak. Why would their oil be showing increased sodium levels without a coolant leak? What is different about them? If you guess geography, you're probably correct. Michigan, I've been led to believe, gets a bit of snow in the winter and combats it with large amounts of road salt. This is what was found to be the culprit for this phantom coolant. These are just some examples, but I'm sure you can think of many others. Each company has unique situations that require unique solutions. We're going to go through a couple of real-life examples of how ALS has solved some unique problems faced by customers today using data analysis. The first one we're going to dive into is wear alert levels, just like the first example. We're going to go into a little bit of math, but I'll try to keep it more interesting than your, high school algebra class. Oil analysis wear alert levels are typically generated using ASTM D7720 as a guidebook. It uses the average of an analyte plus 2 times the standard deviation to discover what is abnormal. Essentially, they take a look at the population of, say, hydraulics, for example, and anything over the roughly 95th percentile is considered abnormal for that compartment. As we talked about before, in order to get these populations, a large net is cast across many different types of hydraulics. This can range from a 2-port capacity up to 200-gallon ones. Obviously, when you're looking at such disparate populations, the standard deviation, or the amount that numbers vary, tends to be quite large. These alert levels definitely do the job. They've been working for, many, many years, but getting more specific will help a company immensely in trending their equipment. Using data analytics, we can get as specific as the client wants with customized alert levels that accurately reflect the situation on the ground for that customer. In this real case study, a customer is wanting specific alert levels for their large stationary generators. They felt the generic ones were too broad for their applications, so they enlisted ALS to come up with some more specific limits for their company. Luckily, they had been sampling for quite some time, so there is a wealth of data to pull from. In the snippet below are displayed the generic iron wear limits calculated across many generators from outside the company, the calculations using the ASTM method inside the company, and limits calculated using a slightly different method that can also be utilized. As you can see, the new limits are roughly 10 to 30 parts per million lower than their generic limits, meaning that this client has a much lower average deviation when compared to the other companies tested. For them, an iron value of 50 parts per million is a statistical outlier, whereas it would be completely normal in the overall population. We also alerted them to how many more samples would be flagged as a result of the changes to wear levels. We want to give complete transparency to not only how our wear alert levels are calculated, but how they impact the program as a whole. These wear limits can also be as specific as we have information for. For example, if you're running 10 different types of engines, we can generate wear levels for each specific type. As long as there is a filter for the data to be parsed through, we can use it in our calculations. In this case, though, the customer went ahead with a calculated limit change and are now catching problems that weren't immediately apparent when they were using the generic limits. Many pieces of equipment were maintained before the problems could become failures. Oil drain optimizations are another area where data analysis can come in quite handy. There are many sources for what is a quote unquote normal drain and what are acceptable limits for oil health tests. A vast majority of the time, it is best to listen to oil suppliers' recommendations. But with easy access to the internet, it is simple to find differing anecdotal recommendations from sources that may or may not be less than reputable. And while it's always best to use oil manufacturers' recommendations for the upper limit of your drain interval, to truly see the most optimal drain interval for your equipment under your unique circumstances, it's best to look at the data. For this case study, a customer had been running a 25,000-mile drain interval since the owner founded the company. The oil provider had been suggesting they can move out to a 40,000-mile drain interval, but the company were a little unsure about how that would impact their fleet. They approached ALS in order to determine if their truck could handle it, or if we selected a portion of their fleet to test this new drain interval. For the study, we monitored viscosity, oxidation, base number, and boron. Boron was included as it was a dispersant in this particular fluid, which keeps sludge formation to a minimum. After running the trial, we discovered that the fluid was not reaching any of the thresholds set by the oil provider and was perfectly stable throughout that period. They were able to see the boron working as intended, viscosity staying stable, oxidation was not reaching its threshold, and base number stayed above its minimum limit. After correlating the fluid parameters to the wear of the engines, they were able to gather the evidence needed to confidently extend their drain interval by roughly 60%. Now, this only worked due to consistent and accurate sampling, but extending drain intervals can be applied to many different applications and components, no matter what the industry you are working in. But investigating the internals of your equipment isn't the only information that can be gleaned from oil analysis results. You can be a little more abstract with it. Maintenance proficiency is something every company tries to maximize in order to make sure they are getting the most out of their equipment. Hidden within oil analysis data are many pieces of information that you can use to discover just how careful your maintenance team is when performing their duty. This study was performed on an over-the-road trucking fleet who wanted to discover if all of their locations were performing the maintenance and filling out the forms correctly. ALS gathered all of their oil analysis information and looked at it on a location-by-location basis. First, we looked at all the sample severities by location. Now, we couldn't just look at the location who submitted the sample, as they weren't the ones who worked on the equipment last. So we looked at the location who performed maintenance on the unit previously. What we found was that several locations were showing increased rates of abnormal and severe severities when compared against the rest of the company, specifically for dirt. We found that those locations were having higher incidences of pencil whipping or not filling out the forms correctly. We even were able to discover the dates in which most of the poor maintenance performance was performed. The company was then able to use this information to trace the problems back to a few managers at these shops that were not following maintenance procedures and were essentially leaving sample bottles open to collect dust. Now, again, I admit this is a very specific example. However, the same methodology can be applied to not only, this kind of application like trucking companies, but any company that has multiple or even just one location they want to monitor. These can all be edited to exactly how you want to see it. Along with maintenance practices, part choice is another difficult decision for many maintenance teams. Any large business will inevitably gather multiple different variants of the same basic inventory to try out, competitors. What this creates is a massive headache for anyone who has to manage that inventory, as you typically will have to work with many vendors and suppliers. For example, it's not uncommon to see that same trucking fleet from before accumulate several different fluids, unit makes, compartment makes, and unit models as time goes on. Most of them, as you're aware, work pretty well. However, the only way to truly know how each are performing is to dive into the oil analysis. For this company, they were in the exact situation that I just described. They are using two different truck manufacturers with two different models each, along with three separate fluids, depending on where each location was geographically located. As you can imagine, this caused a massive headache for the maintenance department. And to make matters more complicated, they were moving to an extended drain. They reached out to ALS to discover which model and fluid could handle the extended drain best for their procurement department to moving forward. Just like the previous example, they used a portion of their fleet using each of the variables to determine which was best suited. This slide shows the different models at the new drain intervals. The non-normal samples were evaluated based on wear and oil health while excluding contamination. The models were all relatively similar, but it became clear that there were some that could handle the drain interval better than others. The maintenance department was able to pinpoint the model that could best handle the drain interval and took steps to only procure that model moving forward and slowly age out the models that couldn't handle it. As for the fluids, we analyzed those as well. The fluids were evaluated on the recommendations from their respective oil suppliers and the averages above the specific drain interval in question. The overall severities of each of the oils was also compared to the results. When also compared to the results were striking. Oil 3 showed relatively normal oil degradation levels, but the equipment it was used on was showing massive amounts of severe samples, mostly attributed to wear. Oil 2, on the other hand, was showing extremely elevated levels of degradation, and that was causing many problems as well. Finally, oil 1 was selected moving forward as it was showing an average level of degradation and the lowest overall severity. These averages were calculated from the units above the drain interval to make sure that if trucks that exceeded the drain interval wouldn't cause irreparable damage to the unit. Ultimately, these are all just examples of some of the uses of data analysis of your oil samples. Other customers have expressed interest in seeing what, kind of metallurgy their parts are made of, or which units are suffering the most from contaminants such as dirt. Fleet management can also be made easier by identifying common failure modes in problem units, as well as seeing a bird's eye view of the entire fleet. Advanced fluid and compartment monitoring are also benefits. These are all just suggestions based on what other customers have wanted, though. Realistically, as long as there is data, we can utilize it in a myriad ways to try and help you get the most out of your oil analysis program. By utilizing ALS's technical network, we can help you get on the path of understanding your data and taking advantage of it. We provide one-on-one consultations and support to build out the pilot projects that you want accomplished. This can be in the form of short-term data analytics deep dives or as a reoccurring report that you receive directly to your email and can be discussed with your consultant. All, of course, with our technical team helping you every step of the way. If you have a problem that you have not been able to quite solve on your own, or if you think that you might have a good use case for data analytics, please reach out to the customer service team to set up an appointment. Let us help you get the most out of your oil analysis program. We are now going to open the floor to questions. Everything that you see on screen here will be, the emails that you direct your inquiries to. And then, yeah, that's time for questions.
Harold, thank you for the presentation. Excellent work. We had a couple of pre-meeting questions come through to myself, so I was just going to ask those now, and then remind people that if you want to ask a question, if you can put that in the Q&A area of the Teams banner, then we'll be able to start to address those questions. So the first question that I got sent to me, Harold, was, I'm not currently testing with ALS. Can we bring our data from another lab for your analysis?
Yeah, that's actually relatively easy to do as long as I have access to the data in a file format that I can use on Power BI or through Python, something like that. Then I will be able to analyze your data. Obviously, I can't hook into another company's database or anything like that. But if you have a file, feel free to bring it over to us, and I can take a look at it and sort of see what's going on.
Okay, the second question that had been sent in is, can we run analysis on a program that has just started?
Yeah, this is in when looking at data, it's more data is always better. So if you have thousands and thousands of samples for us to pour over, obviously that's going to be the best case scenario. But that doesn't mean that we can't do something if you've just started. Usually that we can't do anything like deep dives into how each piece of equipment operates. But as far as like the maintenance management side, we can get on that early and track that kind of stuff. Even if you are you don't have any data pre in our system, we can track moving forward and sort of build something out like that.
Okay. Okay, so we did get a question in the chat. And so the question is, the users in Mexico, do we have call center people in Mexico that can speak Spanish?
We do have Spanish-speaking
Yes.
customer service reps. You might be able to answer this a little bit better than I can,
Yes,
Michael.
I can. Yeah. So we do have local language speaking representatives at our facilities in Mexico. So if you call there, they will speak in local language, as well as if you are looking for another support in our Phoenix lab, we do have some Spanish-speaking representatives in our Phoenix lab. They may not answer the phone immediately in Spanish, but if that's needed, you can certainly reach out to myself. My email's there, michael.martinello@alsglobal.com, and I'd be happy to support you.
Michael, do you want me to read the questions or do you want me to read them out loud?
Sure, you can read them if you want.
All right. I'll start. at the bottom. So can you share condemning limits with us, i.e. oxidation, nitration, wear metals, etc.? That's a little complicated. So yes, anything that is done in-house with ALS, we can share those condemning limits with you. So let's say it's a generic diesel engine. We can share condemning limits for, the wear metals and anything that we come up with in-house. Anything that is given to us by an OEM, whether that be, the equipment manufacturer or the oil manufacturer, that is proprietary information and has to come through them. Now, if we, and the same kind of logic applies to if I build out unique wear limits for you, that is sort of covered under that proprietary information, and I can't share that with anybody else. But we do anything that is generic and in-house, we can share. I want to say that there might be a technical document for that, but if there's not, we can get one together and publish it on our website. Now, I do like to stress that the condemning limits are not a hard limit. A lot of the time, the diagnosticians might see something that is, concerning prior to hitting those condemning limits. So let's say iron condemning limit for an engine is 100 parts per million. If a diagnostician sees it jump from 5 parts per million to 60 parts per million, they're going to flag that, even though it's under the 100 parts per million limit. It's just based on increases and decreases and how that individual unit behaves. But short answer, yes, we can share limits that we have provided or that we have calculated, but anything that is from outside our purview, then no, we cannot. Next question is, can you pinpoint road sodium versus coolant sodium? So yes, typically coolant sodium is accompanied by other elements. Most coolant formulations usually have either potassium or boron or moly or silicon, something in there other than sodium. If sodium is elevated by itself, it's usually indicative of road salts, or if you live on a coast, it's from, just seawater getting in or just ambient salt water in the air. But typically that's how we do it. I have seen situations where coolants only have sodium, but those are pretty rare at this point. Right. Next question. Some say base number has become almost irrelevant. Please give your opinion on that. Yes and no. There are a lot of oil manufacturers that have moved on to much more advanced additives, and they don't really, base number doesn't really make sense to them anymore. But there are also a lot of oils that still utilize base number to sort of tell when their oil is wearing out. It definitely does not have the end all be all, a status that it used to have. More often now, I've seen people move to viscosity and oxidation, nitration, sulfation, and even acid number as opposed to base number. But it does still have its place with a lot of oils. It just kind of depends on the technology that most oil companies are using now. That is all the questions I see, unless anyone has any more that might be in the chat or something I'm missing.
We will look 1 second.
Yes.
I have a question in the chat. Would you like me to ask it for you, Harold?
Yeah, sure.
Do you see any major difference with samples that change oil filters every other oil change on aircraft?
Ooh, that's actually a really good question. I have personally not done a lot of analysis on aircraft in particular. But I will say that uh, the more often you change your oil filters, generally the cleaner your oil is going to be. I know that sounds sort of self-explanatory, but a lot of these oil filters will gather all of the debris that sort of comes up into your fluid, and over time they will just fill up. And depending on how small those filters get down to, what you know beta rating that they get down to, they can fill up pretty quickly. And the longer you put off changing your filter, the less effective it's going to be in general. So I can't really answer your question on aircraft in particular, but just in general, that's kind of how I see it. Um, okay, I have a couple new ones. All right. So I have a question referencing viscosity. We've had a history of low viscosity, interval reduced to 250 to 200 hours, and heat exchangers checked. As a last resort, we had a new oil tested. Nominal viscosity was 15.5, ALS tested at 13.6. Dry questions, the sample is retested at 14.7, something like 8% variation on the same oil. If the reliability of viscosity testing of this magnitude, can we rely on low viscosity alerts? So in this particular situation, I'm not sure what caused the low viscosity reading on ours. It could have been a one-off. We do have human beings running the laboratory instruments here, and so there is a level of human error that can come into it, or just instrument error on that particular day. We do run uh, 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 I keep forgetting the word, like it's just charts to make sure that everything is falling in line every couple of samples. So we do have documentation proving that our instruments are falling within the realm of accuracy and reliability. Now, this could have been like I said, this could have been a one-off. If this is a more, common occurrence, please reach out to me via email and we can get to the bottom of that. Do you see, another question is, do you see any major difference with samples that change? Oh, no, this is one I already saw. Um, I, I operate a small general aviation aircraft with a four-cylinder geared piston engine. I'm doing analysis every oil change and at 100 hours of operation. The specific track times are generally items are generally the metals and the engine components. I'm going to track the specific condition of that oil's properties. Seems like there would be other things that are not currently checked and monitored. How would I get these other things monitored? Um, so if I'm understanding this correctly, it seems that you're only testing for the metals in the engine and not any of the other oil properties. In that case, you can definitely reach out to our customer service team and we can get you a expanded test slate. Um, It'd be specifically very helpful to make on aircraft to make sure that the engine is not overheating and that the oil is not wearing out prematurely. But yeah, feel free to reach out. You can reach out to the uh, probably Michael on this, Michael Martinello at alsglobal.com. He should be able to point you in the right direction if you don't reach out to our CSRs directly. All right. Talk about statistical process control samples. Yes, in all of these projects that we do have controls on all of them. So, for instance, let's say when we're looking at all of the comparing the different oils, we want to make sure that the oils have a pretty large gambit of different types of engines that we're running on. So they were running four different types of engines and three different oils. So each population that we looked at had each variable taken into account. So we're not getting any false positives or anything like that. I try to keep a control sample for every project that I do. Obviously, that doesn't make sense for some of them, but for the most part, we want to have a control sample to see how, whatever we're trying to prove is going to stack up versus reality. Is there any more that I may have
I
missed?
don't see any more questions. Okay, so if we don't have any more questions, I'll just explain a little bit about, once we end the meeting, the invite, you'll all get a copy of the presentation message to you. If you have a problem with that, feel free to reach out to myself, Michael Martinello at alsglobal.com. I'm happy to support you in getting that. If you were not able to get a question that you wanted answered today, please feel free to ask the question via email, and we'll set up time to respond back to you.
And on top of that, if I, these are live in front of people, so explaining a question might be a little more difficult just off the cuff like I have. But if you email me your question directly, I can provide a, longer form response to it. And that goes kind of for anything, not even just regarding these kind of these pilot projects or anything like that. If you have any questions, just generally about oil analysis or how the process works or any of that, please feel free to reach out directly to my email.
Well, thank you everybody for joining us today. Harold, thanks again for a wonderful presentation. Look forward to answering any further questions anyone might have, via email or phone. Thanks again. Have a great day, everyone.
Thank you.